Okay, so like I said, the multiplying and dividing should have been really straightforward. You're just factoring and then canceling like factors that show up in the numerator and denominator. There's a little bit more going on when you're adding and subtracting rational expressions, which is what these are. These are just rational expressions. So how do you actually add these together? Yeah, you need a common denominator to do that. And so then once you have a common denominator, how do you add fractions?
You just add the top and the bottom.
Add the numerators, leave the denominators as they are, and then you should check to simplify. So on this problem, what would the common denominator be? 36. Okay, so now how did you get 36?
It's the least common factor.
All right, so at least common multiple of both 9 and 12. Okay, so it's what they both go into. Does it have to be the least common multiple to work? No, it could just be anything that has the same denominator. Why would there be more work? Okay, so there'd be more to simplify at the end. Okay, so if you're not picking the smallest one, you might have more to simplify at the end. So you could do this problem by just, so how did we get to 36 when we're at 9 first? All right, so then you can't just multiply the denominator by 4. You have to multiply the numerator by 4. Why is that?
If you do it to the bottom of the equation, it keeps the fraction equivalent.
Okay, so everything you guys said is right. This is like multiplying by 1. So 16 over 36 is the same as 4/9. And so then what about, right, because then we're multiplying by 3. And then you add them together for 31 over 36. Is there anything to simplify there? Okay. So, that's the least common multiple, but there's nothing that says that we couldn't do the first fraction by 12 over 12 and the second one by 9 over 9, right? But then, like Devin was saying, then there's just a lot more to simplify at the end. So everything's the same idea, but I'm going to try to get us into a better spot. And I'm going to do the same problem, but I'm going to rewrite this as prime factors. So what are the prime factors of 9?
3.
And then what are the prime factors of 12?
2.
So 3 and 4, but really 2, 2, and 3. Okay, so looking at it written that way, why does it make sense that we multiply the first fraction by 4? It's in the form of 2 and 2. So can you say that a little bit more? Can you say that in a different way? I know it's kind of a weird thing to ask, but you picked 4 because more basic way. Okay, so both things need to be equal, and so what was missing from the first one? Well, that 2 and 2, right? And so then that's why we ended up multiplying by 4, because we called 2 times 2, 4. Okay, and then on the other one, we multiplied by 3, because that was the one that was missing there. And so really our common denominators were 2 times 2 times 3 times 3. Is that okay with everybody? And so we were just looking for the missing factors. Does that make sense? This one's actually easier than the one that we just did, I think, because it's already prime factors for you. So the way you want to go through this is to figure out what the common denominator is going to be. And it's like Brayley said, it's kind of like you're just looking for what's missing from one of your denominators, but is in the other denominator. Now, of course, there's 3 here, but that's not a big stretch. So it's going to be x's and y's, but how many x's are we going to need to get a common denominator here?
2.
Why are you saying 2?
Because the biggest exponent is 2.
Okay, because it's the biggest one. You can't go smaller. There's nothing to reduce. So it has to be x squared. Is that okay with everybody? Okay, then how many y's do we need then?
3.
Okay. So is there any questions on why this is our common denominator? All right, and so then to figure out what you're multiplying the numerator by, you're just looking for what's been added, or multiplied is a better way, into the new common denominator that was missing from the original one. So, we're just looking at this for right now and say what's missing from here that is now part of our common denominator.
X, Y.
All right, so we needed both an x and a y. So then we'd multiply that up top. There's already a 1 there, but now there also has to be an x and a y there. Is that okay? What about the second one? There was already a 2 there, but then it's missing an x. And so then we have to put that up here too. And then the third one has a y already,
X squared, Y squared.
but we already had an x squared in that one, right?
Oh.
So what was missing from that denominator? That isn't y cubed. So then, for this one, I'm just going to write it y cubed, but really, then our new denominator there is going to be y to the 4th. Is that okay? It's in a math movie. But I'm going to rewrite this a little bit more expanded so that you can have a better idea, because we want the smallest denominator that we can get so that we don't have to do a bunch of simplifying later. So really this first one is 2 over 3 times 3 ABC. And the next one is 2 times 2 times 3A. And the last one is 2 times 2 C cubed D. Is that okay with everybody? All right, so then we want some common denominators. And so then the common denominators, let's do numbers. So, all right, but I want to do it as, not as 4, I'm going to do it as 2 squared. Okay, so then 2 squared. Okay, so hold on, 2 squared. What else has to be down there? Oh, no, hold on. Yeah, carry it on. So we need 2 2s. How many 3s do we need?
3.
Do we need 3? That's a good question.
We just need 2. 2.
Well, how many do we need?
2.
So that's the most, so let's just stick with 2. If you did 3, we'd have to, man, I keep saying 3 and I keep writing it. Right, if you do 2, then, or if you did more, then you just have something that you have to simplify. It wouldn't necessarily be wrong, you just have to do more later, okay? What about A's, B's, C's, D's? How many do we need of them? 1A, 1B, 3 C's, and 1 D. Is that okay with everyone? No, we need 3 C's just for the same reason we only needed 2 3's. Is that okay? All right, so then our final common denominator would be what? Let's just take care of that right now. 4 times 9? So 36, A, B, C cubed, D. All right, so then, there was a 2 on this one, there was a CD on this one, and there's a -5 on that one. So now we're just comparing denominators. So what's missing from this first one that is now in our common denominator? All right, we need to get 2 more 2's up there, so 2 squared.
3 squared. No.
Right, the 3 squared is already there, though, right? Okay.
So then just A, B.
Do we need an A and a B?
No.
No, because it's already there.
So C squared and D.
All right, we need C squared, because we only had 1 C there. We needed 3, and then we need a D. Is that okay? And so that final one would be 8 C squared D. All right, what about the second one there? What the? All right, we need a 3, yep.
B, C cubed, D.
B
No. Yeah.
C cubed D. Is that okay with everyone? That was what was missing, right? So then, yeah, I can see that.
You want to know
All right, so then this should be, yeah, I think that's what it is.
no, it's
Right.
time to get this.
All right, is that okay? I feel like that's right. We've had a lot of distractions.
Not C to the fourth, right?
Uh,
Or am I using 3 C's?
well, okay, so we had to put in 3 more C's, but there was already a C in the original numerator. And so now it's C to the fourth. Is that okay? All right, so one more here. What's missing that we had to put in there?
3 squared A, B, D.
A,
No, not B, not B.
just A, B, right?
Just A, B.
All right, so then that would be negative 45 AB. So to me, I think that one's actually kind of harder than the next one we're going to do. Maybe you'll disagree.
That was a pretty long process.
That is a long process, and it's easy to miss. You got so many C's and D's running around, and so, you got to keep things straight when you do it. What?
No.
What happened? Did I misspeak?
No.
All right, so this is more of the, I think these are easier. Focus. Focus. All right, so the first step should be getting prime factors. So what can we do with the first denominator there? No. Take a 4 out, so then what do you have left over? X what? X minus y. All right.
So you factor these before you find your greatest common?
Well, we kind of factored those ones before too. They were just prime factors. Like on that last one, they were kind of already factored for you. Okay. And the whole point is you want to you don't want to simplify big crazy things later. Okay. Like the one that we just did, that wouldn't be very hard to simplify because it's all just C's and D's and no big deal. But if you end up just multiplying these two things together, then you're going to have to FOIL and distribute, and then all of a sudden you're going to have combine like terms, and then you're going to have something that you don't want to mess with. Okay. So you do want to factor and multiply by the smallest factor you can. So what about the second denominator? What does that factor into? That's the difference of squares, so what is it? Okay. So then our common denominator is going to be, so right now this is 3 and this is x. So what's our common denominator going to be? 4 for sure.
4x plus y, x.
No,
4x plus y, x minus y. Is that okay with everyone? I actually might. I feel like because I was just gonna ignore it, but then it's like I actually like that. That would be fun. See if I can get any thumbs up from the crowd that likes my voice. Maybe it isn't as big. I'm just gonna surround myself by people that like my voice, and that way I can feel good about it. All right. So then, what's missing from the first denominator that we need to get in there?
X plus y.
So then it's going to be 3 parentheses x plus y, and we're going to have to distribute that later. What about the one that's missing from this other one? 4. Right, because everything else was there? Is that okay? How's that? Is that all right?